OpenShift integrates, monitoring and log management to provide really immediate metrics back to developers in order for them to study how an application is behaving across, changes, and they're able to fix those issues as early as possible in the application lifecycle. And so I think it's important to explain, how we build OpenShift. So, Red Hat, we have, obviously this 100% open source development model to deliver, enterprise products. And, so there's no forking, no rebasing, there's no proprietary extensions. And really, one real key to that is our ability to turn, dozens or hundreds of these open source projects into a production-ready, stable, and secure enterprise product that we then support over several years. And so when the community declares a release ready, we typically will find hundreds of defects that we then fix and we ship in the corresponding downstream release. And so we can do that because specifically with Kubernetes, we've been contributing to Kubernetes and a lot of these other projects since day one. In fact, Red Hat is the largest enterprise developer of Kubernetes besides Google, who's the project sponsor. So, we've been in the game as far as contributing to Kubernetes upstream and making sure that it's actually enterprise grade. And as of May, we actually just started shipping OpenShift 4. And with this foundation, we add a lot of enhancements to deliver, a platform that has all the components that you need, and they're all fully integrated to really build and deploy and manage these containerized applications. So, in a lot of ways, OpenShift 4 is a smarter Kubernetes platform because we've streamlined things like the installation and upgrade process. You can be up and running, with a fully configured Kubernetes cluster in less than 15 minutes, but you'll have everything you need with OpenShift as far as metering and monitoring at the cluster level or application to developer services, Kubernetes updates, security patches, components, all these updates can be deployed with a single click. And so based on RHEL CoreOS, which is really kind of a lightweight, container immutable OS, OpenShift can actually update the underlying OS as well. And it scales at the node level, which is really useful when you deploy OpenShift on cloud infrastructure because, the entire cluster can scale up and down based on your application needs. And so you can essentially scale from, 10 containers to 10,000 with the click of a button. And so, ultimately creating value for both, external and internal customers, it depends on your ability to deliver applications faster. And, we believe that, containers and Kubernetes and DevOps are the key ingredients that a modern application platform should be based on that will allow you to transform your traditional apps, build cloud native applications, and also experiment with things like analytics or machine learning and serverless applications. The application platform needs to provide a consistent way for developers and operations teams to collaborate across all deployment footprints, from edge and air-gapped environments to infrastructure you have in your own data center and all the way to the hybrid cloud. So a couple other features that OpenShift 4 introduced. So, customers aren't just, struggling with the installation piece, which is why we've made it a lot easier to deploy in an automated sense, but they're also struggling with the upgrade piece and staying up to date with the latest patch and feature releases. And so our goal was really to not just simplify the installation, but to make upgrades seamless through a completely automated over-the-air update model. And so we want to make upgrading the platform as easy as upgrading your mobile phone. And then from a security piece, security, especially DevSecOps members, are often the first teams to get pushback when adopting containers, and a lot of that is because you're having to understand, how do I defend the infrastructure piece and the applications themselves? And static security policies and checklists, they no longer cut it, and they don't scale for containers. So to truly get the advantages of containers, companies are having to evolve their approach to security, and it has to become a continuous activity, and it has to be considered at every stage of your app and infrastructure lifecycle. So doing it right, you're planning up front. You have more integrated security solutions, and that leads to faster app delivery. And so securing containers is a lot like securing any process. you need to think about security throughout the layers of the stack before you deploy and run your container. And so you also have to think about, security throughout the application container lifecycle. And so what this kind of demonstrates is really the three major categories of enterprise container security solutions. So you have to control the security of your containerized application. You have to defend your container platform infrastructure, and you have to extend the security of your overall solution by leveraging the tools from the broader security ecosystem. So we talked about that a little bit before, but the infrastructure is Linux. So defending Linux is going to be the same as what you've been doing before. The nice thing is these containers themselves, they have those same Linux dependencies. So you're able to leverage things like cgroups and SELinux namespaces to secure those applications the same way that you would the underlying OS. And then, ultimately, no matter what infrastructure you choose, OpenShift is providing the tooling and the process automation to really enable teams, to operate Kubernetes efficiently and economically. And so, being able to run on whatever infrastructure you choose, having things like automated operations, it's secure by default, it's running on Linux, monitoring and chargeback is a big piece as far as application access, and you can kind of plug and play with a lot of the tools that you already have. And then, one of the big things that we've just rolled out is operators as part of OpenShift 4, and the community it was birthed by the progression of app workloads on Kubernetes. So now we're running complex distributed systems. They require concepts above the built-in objects like stateful sets, deployments, things like data rebalancing and doing seamless upgrades of these complex apps are a huge key component of Kubernetes. And then here you can kind of see what changes have been made from OpenShift 3 to OpenShift 4. We're now bringing a full stack install, all automated on immutable infrastructure as part of OpenShift 4. So on the left, you can see how the OpenShift 3 installer works. You first have to configure the underlying infrastructure, then you deploy RHEL, and then you install OpenShift on top of that. But from there, OpenShift and RHEL are upgraded and managed separately, and they have to remain in sync. Whereas on the right, you can see how OpenShift 4 installer works. It's OpenShift 4 includes RHEL CoreOS as a component of the product. And so OpenShift 4 will first configure the underlying provider. It then spins up the CoreOS nodes, and then you deploy your Kubernetes cluster and the cluster services on it. And so you go from configuring and managing 3 entities to a single full stack automated installation process. And as part of that, we've automated not just the installation piece, but essentially all of the day 2 operations as well. And so the self-hosted process, it makes upgrading the clusters a risk-free and repeatable task, and it's really as simple as I said before as updating your iPhone. You also have the choice for your operations teams that they prefer a more customizable or mutable installation, on top of traditional RHEL. And so that allows them to install and manage those clusters in whatever way the organization has sanctioned. And so, automated operations are based on implementing operators throughout the platform, and that's something that's new into OpenShift 4 that we just released back in May. So a couple other things I wanted to touch on, because you're translating these best practices into kind of Kubernetes concepts, you're not just reinventing the wheel. You end up with a really truly hybrid application. So operators, they function the same no matter where they're running. And the operator framework, it's a set of tools that helps you build and run operators on a cluster. And it includes an SDK that helps you get up and running. Not to mention that, we include inside of the Operator Hub, which I'll talk about next, hundreds of these different operators. Some of them are going to be, kind of upstream within the community, and then we have OpenShift certified operators as well. And so this is built into the platform. It's a single place for, developers to publish their operators, and then for you to find and consume those operators. And, they meet, quality standards, so you have confidence that they, deliver what they promise, and you can deploy those operators on any Kubernetes distribution, not just OpenShift. And ultimately, that provides, full control for your administrators. Inside of OpenShift, admins have full control over which operators are installed across the cluster, and they gain tools for upgrading them from the central point. And ultimately that leads to self-service. Engineers are going to interact with the operators in a self-service manner, just like any other Kubernetes object. So here you can see kind of what a developer's view of the operator capabilities that are exposed to them, all with self-service access to manage them. Okay, so we've talked about containers, Kubernetes, and OpenShift. Let's talk about now what kind of options we have as far as training, getting up to speed here at Red Hat. And so one thing that we like to walk people through is this container adoption journey. What is it? So depending on where you are in your container adoption, kind of dictates where in this journey you fall. But for those that are early on in their adoption, they're really in that discover and pilot phase. And what we have to offer them is helping you to understand not just how to deploy the platform and how to deploy applications into it, but how do you start to move towards that DevOps mindset? How can we get maybe your core adoption team up to speed with the platform and with this new paradigm of actually developing? And so if you take a look here, this is the same container adoption journey, but it maps to different curriculum offerings. And I'll go through what some of these are. But essentially, in that discovery phase, what we want is for the adoption core team to go through a DevOps culture transformation, and then go through an introduction to containers, to Kubernetes, and to OpenShift. And so what those SKUs are, the DO500 I'll mention, that's our DevOps culture and process enablement course. It's essentially a 5-day immersive experience to allow you to really kind of jumpstart your DevOps transformation or adoption. And so what it is essentially us going through with you 40 or so different DevOps processes, right? So things like Scrum, things like pair programming, mobbing, looking at the benefits of CI/CD tooling like Jenkins. You're getting exposure to a lot of these different tools, and we're going to work with you kind of hand in hand with your organization to really get the most out of that and kind of cater it towards your exact use case. Beyond that, we have really technical. That's where the 180 comes in. So, beyond that, we have the DO180 and the DO700, and I'll talk about those in depth in just a second. But, essentially, we have a lot of curriculum to offer from the OpenShift standpoint. And so, first and foremost, we have our introductory course. So that's really what this webinar is mapping towards. Our introduction to containers, Kubernetes, and Red Hat OpenShift is essentially a 3-day course where your teams will actually go through understanding what containers are. You'll work with containerizing applications. You'll get some exposure to